A very good morning, students. In today's class, we would be talking about the Lewis concept of acids and bases. Now, according to this concept, this is an electron-oriented concept. Everything that we decide about the identity being an acid or a base would be on the basis of an electron. Acid is an identity which accepts electrons, while a base is an identity which donates an electron. Therefore, when I talk about bases, anything can donate electron only if it has electrons. कोई electron donate कब करेगा? जब उसके पास electrons extra होंगे तभी तो. So, all electron donors are generally of the type this. What's common in them? The charge. So, all negatively charged ions, because of these negative ions, because of this excess electron shown by the negative ions, these identities, which we commonly call them as anions, are electron donors and they can act as bases according to Lewis. Apart from the negatively charged ion, there are molecules like ammonia. In ammonia, you have one pair of electron which is not bonded. Similarly, you have another water, which also has another pair of electrons where oxygen has two such pair of electrons which are not bonded. Hence, oxygen has the lone pairs, hence is capable of utilizing these electron pairs for some kind of coordinate bonding. So despite the fact that these are neutral molecules, they can act as Lewis bases due to the presence of lone pair in them. Coming down to the acidic part. Acids are electron acceptors. Now what kind of an identity would like to accept electrons? किसके लिए electrons accept करना easy है? जिसको electron चाहिए. What is the charge on electrons? Negative. So any identity which is positive in charge can easily accept electrons. Hence, all cations would fall in this category of Lewis acids, where these Lewis acids would easily accept electrons due to these charges. There are other identities of the type BF3, BCl3, BeCl2 or anhydrous AlCl3. We'll talk about anhydrous AlCl3 in detail after a while. Presently I am talking about BF3. A BF3 identity is written like this, and you never write BF3 like this. Why so? This is representing 3 electrons given by boron. Boron ने 3 electrons दिए, एक electron तीनों F को. So this would represent a ionic bonding, which is never observed in case of boron. The reason being, the size of boron is too small. This is the first member of the 13th group. So electron loss from a small sized atom is very difficult. Losing 3 electrons, पहले एक, फिर दूसरा, फिर तीसरा. After losing 3 electrons, for only then can it form a +3 ion. And losing these 3 electrons will require a large amount of energy. That is, your ionization 1, 2 and then 3 would be extremely high. Therefore, boron is normally found to form covalent bonds. This boron has got 3 electrons in its outermost shell and 3 it shares with these 3 fluorines. Thereby, now it has 6 electrons in the outermost shell. Therefore, it is electron deficient. Being electron deficient, automatically it becomes electron acceptor. Therefore, it is called as a Lewis acid, as I represented by the word La. This can be further illustrated. Supposing I have a molecule of ammonia. This is an ammonia molecule, and I combine it with a BF3. Now, BF3 is a Lewis acid, electron acceptor. while ammonia, due to the presence of lone pairs, is rich in electrons, so it is a Lewis base. When they combine with each other, this is what happens, where this arrow is illustrating the coordinate bond formation between nitrogen from its lone pairs towards boron, leading to the boron acting as an acceptor while nitrogen is acting as a donor. Talking about the anhydrous AlCl3, as I had just mentioned, in case of an anhydrous AlCl3, AlCl3 is expected to form something like this, giving electrons to the 3 Cls, leading to Al changing into 3 positive and the 3 chloride ion formation, which is your ionic bonding. But again, formation of Al3 positive would require a large amount of energy, since it would need the 3 ionization energies. This value of the ionization energy is extremely high. Therefore, ionic bond formation is difficult in AlCl3, but if it is an aqueous medium, this is fine. You have an ionic bond formation. If you are talking about AlCl3 aqueous, this is correct. But no sooner I call it anhydrous AlCl3. What do we mean by the word anhydrous? Means no water. If there's no water, then ionization energy is not compensated. Since there's no water, water naturally is providing the hydration energy, and this hydration energy compensates for the high ionization energy. In these circumstances, aluminium cannot lose 3 electrons and is forced to form 3 covalent bonds with 3 Cl atoms. Al now has got 3 electrons of its own, 3 shared with the 3 chlorines, leading to 6 electrons, which therefore is electron deficient and hence a Lewis acid. So, when you talk about this particular compound, this is covalent. This is electron deficient and hence is a Lewis acid. So, I conclude your Lewis acid base concept is electron oriented. Thank you.